Now we are going to look to the some interesting and important properties of organic, that is alkane, alkene, alkyne, etc. Mind you, I am not going to talk here on the screen any of the reactions which are very easy and which can be read directly by reading in books. Please understand. Wherever I feel they are important, I am talking of the same. I am not going to talk of something very easy, whether it is important or it is unimportant. I am going, please see. Now we will see ozonolysis. As you observe on the screen, that is ethylene, the reaction of ethylene with ozone, we will see. What is happening? Please see on the screen, CH2, O, O, CH2 and O as shown on the screen. Bonds are completed. Now the two vertical lines you see plus H2O, that is hydrolysis. What will happen? It will give us HCHO plus H2O2 plus HCHO. Now please understand again. Or after hydrolysis, what will happen? The oxygen on the place of double bond, the portion on on one side of vertical line and on the other side of the vertical line will be written separately. Like you see HCHO plus H2O2 plus HCHO. So this will be a trend always in all cases of ozonolysis. Please follow it forever. See again, HCHO, that is CH2O will be written as HCHO plus H2O2 plus again CH2O. If there is something else in place of this one, then we will write accordingly. Now please see another example. Like for example, CH3, CH, double bond CH, CH3, that is 2-butene. When ozonized, it will give what? CH3, CH, O, and as shown on the screen, the bonds are completed. Please see, the double bond will break down and in between we will insert O, and as shown on the screen, please see it. Now again on hydrolysis, what will it give? The part on one side of the vertical lines will be separately, the two parts will be written separately. Now please see what will happen. It will give us CH3CHO plus H2O2 plus CH3CHO. Mind it, these are two examples. You can write numerous number of examples. This is one key by which you can open a lock, you can open and get your wealth. We see third example. I'll give you in the form of question. Please see the question. An olefinic, you can see on the screen, an olefinic double bond compound on ozonolysis give two molecules of propanone 2. What is the IUPAC name of this compound? It's a fine question, you can observe. Again I am repeating, an olefinic double bond compound on ozonolysis gives two molecules of propanone 2. What is the IUPAC name of that compound? See, how shall we write? Please see on the screen. We understand that you keep them as shown on the screen, like in front, O and O are kept in front to each other. And now what you should do is remove O and put double bond in between. Name it now. What will be the name? 2,3-dimethyl. Read it and see. 2,3-dimethyl butene 2. This is the answer to the question. There can be numerous number of reactions like this. These are only few examples. Please do more of them. Any other example can appear in PMT or PT or any of the competitions. We will go ahead now. Please see. Now, please see the reactions of HgSO4 plus H2SO4. The reactions of HgSO4 and H2SO4. Please see on the screen, you observe. Very easy reaction we are taking. See, what I have done in this reaction, in books, it is given directly. But now I have shown all the bonds completely visual form. You can observe on the screen. See, C2H2 plus HgSO4 plus H2O4. First, C2H2 plus H2O4. What will happen? Now H2SO4 can be written as H plus HSO4 minus. And now what will it give? C2H2 plus HHSO4 will give CH2 double bond CHHSO4. Now again HHSO4. What will happen by Markovnikov rule? Understand Markovnikov rule, please. The negative part will go to which carbon atom where least of the positive part exists. That is CH2 double bond CH HSO4 plus HSO4 will give CH3 double single bond C H HSO4 HSO4. Please. And now further, see it. Now we will understand ahead. Now hydrolyzed in presence of HgSO4 and H2O4, what will it give? HgSO4 and H2O4, twice HOH as shown on the screen. You'll now please remove HSO4 and put one H. Another HSO4, another H. It will give you twice H2O4. So what will be the total reaction? It will give CH3 CHOH OH plus twice H2O4, which will give further CH3 CHO. Why? Because two OH groups are attached to same carbon atom, so it will give out one water molecule. Now please see, we take up another example. For example, CH3 C double bond CH, that is propine. Propine plus HgSO4 plus H2O4. What will happen? Like we see CH3 C double bond CH plus HSO4 minus H plus. Why we are writing it revert? It is because of Markovnikov rule. We know that HSO4 is a negative part, so we would like to attach it to which carbon atom? CH3 C double bond, that is middle one. Why? The reason is apparent. Markovnikov rule says that negative part will go to that carbon atom where least of the positive part is attached. In sequence it will give us what? It will give ketone. So apparent. Please see, this is again a key question, key answer, and it can cover you one question in PMT or PT of any different example. Now what is, in nutshell we understand, acetylene plus HgSO4 plus H2O4 will give us what? Acetaldehyde. Rest of any alkyne will give us what? Ketones. Now please see some of the properties of aqueous QH. Now aqueous mean what? Solution in water. Now see what are the properties in nutshell, as you observe on the screen too. See, wherever chlorine or any halide appears, the reaction with aqueous KH will be removal of halide, that is Cl, and insertion of OH, that is all. See some of the examples on the screen. Like for example, you see C2H5Cl plus aqueous QH. Simple. What will give? As you know, C2H5OH plus 1. Again, other example will be, like for example, dichloroethane. Which one? 1,2-dichloroethane. It is better to call it in IUPAC system. That is 1,2-dichloroethane plus aqueous QH. That is solution in water. Will give what? CH2OH, that is glycol. CH2OH, single bond CH2OH, that is glycol. What will it give with 1,1-dichloroethane? That is ethylene chloride. What will it give? Apparent. CH3 COH OH. Removal of OH water molecule will give what? Acetaldehyde. Please practice. Now further we see that with any 2,2-dichloropropane or 3,3-dichloropropane, what will it give? Apparent. CH3 CCl2 CH3 plus twice QH will give what? It will give us CH3 C double bond, that is ketone. And furthermore you can see with chloroform, wherever chlorine is attached, chlorine will remove and OH will insert. That is CHCl3 plus 3QH will give what? CH, OH, OH, OH. Remove one water molecule, it will give you formic acid. Now in the next part, formic acid plus QH. Why this reaction is occurring? Because formic acid is an acid and QH is a base. So acid plus base will give what? Salt, HCOK plus water, that is H2O. So net reaction as shown on the screen. Similarly more reactions. So what do we observe? Please see, ethylene chloride, that is 1,1-dichloroethane will give what? Acetaldehyde. 1,1-dichloropropane will give what? Again aldehyde. 2,2-dichloropropane will give what? Ketone. So please see, these are very easy reactions which you can understand very clearly. Many more you can see in various pages. You can collect them and you will be glad to understand that they are what type of properties? Removal of Cl and insertion of OH. That is removal of halide and insertion of OH. Now please see with alcohol.